Where is an individual score located within the distribution? Well, if we have our individual score represented as a z-score, or expressed as a z-score like I do here, this negative 1.50, then it's a pretty easy process to figure out where this is. So let's start with the negative. Now, not all z-scores are negative. They're either negative or they're positive, but this one is negative. And what this tells us is that the score is below the distribution mean. So let's say, for example, that we were looking at a population and the population mean was 120. Now, I don't know what the individual score is, but because I see that it has a negative z-score, I know that it must be a value that is below or less than 120. That's what the negative tells me. We also, however, have this value here, and that's going to tell me the rest. So this tells me that the score is a distance of 1.5 standard deviations from the mean. So if I knew what my population standard deviation was, and for the sake of this example, let's say that it's equals to 12, then I'm going to be able to figure out exactly what my score is. The idea is that if I have my distribution, and at the center of my distribution is the mean, 120, I know that my score is going to be on this side. That's because of the negative. How far on this side? Well, I know that I need to go back 1.5 standard deviations. So I'm going to be at minus 1.5 standard deviations. So the score is going to be equals to the mean minus 1.5 standard deviations. And so that's going to be 120 minus 1.5 times, my standard deviation is a 12, and so this ends up giving me what? 1.5 times 12, that's 18. 120 minus 18 is going to be 102. So I know that this z-score leads me to figuring out that a raw score is equals to 102, but the z-score tells me so much more than just what the raw score is. It tells me where it is in relation to the population mean, how close it is to the typical value for the distribution, or the expected value for the distribution.